Hello, good to be back with you today. This is a solution to the fifth problem for my spring 2020 final exam. Here we're asked to compute a Laplace transform of a piecewise defined function using the definition of the Laplace transform. All right, now there's a little subtlety in here. A lot of people get tripped up because this function has been defined from negative infinity to infinity. But when we compute the Laplace transform, we only want the domain from 0 to infinity. So we got to be careful when we set up our integral that we don't get fooled by the beautiful celebrity negative infinity that shows up. All right, well, let's try writing down our definition of the Laplace transform. So L of f is given as the integral from 0 to infinity of the function f of t times e to the negative st. So this is a decaying exponential times dt. Now, in order for us to compute this integral, we need to know exactly what f is. And of course, it's given up here, but you see it's given piecewise. So what we're going to want to do is break this integral up into two separate pieces, one corresponding to the domain between 0 and 3, and one corresponding to the domain 3 to infinity. So we break this up as the integral from 0 to 3, and on that interval, our f of t is equal to t. So we write t times the decaying exponential, plus the integral from 3 to infinity. And now on this interval, our f of t just becomes the constant 3. And again, we multiply by the decaying exponential. Okay, I'm not too concerned about this second piece. That's going to be a pretty easy antiderivative to find. This first one, I think we might have to do a little bit of work, maybe a little integration by parts. So let's give a name to this. So let's call this g prime of t. And we'll do some work over on the side. So if my g prime of t equals t e to the negative st, I want to know what is my g of t. Well, let's see. I'm going to split this up as t and e to the negative st and use my tabular method. So the derivative of t is 1. An antiderivative for the exponential will be, remember we're differentiating with respect to t here, so this will be negative 1 over s e to the negative st. Then I'll differentiate again and get 0. Anti-differentiate again, and I get 1 over s squared e to the negative st. All right, we draw our lines, plus, minus, and let's see. Each of these has an exponential. So let me pull that exponential to the front. Okay, now this first one also has a minus, and the second one will have a minus. So heck, might as well pull that minus out. And what's left over? Let's see, I have t times 1 over s, so t over s, and then I have 1 over s squared, so plus 1 over s squared. All right, so that's my antiderivative. And so I'm going to be able to compute this integral. So let's head over here by evaluating g at both 3 and 0, and then finding the difference. So I'll need g of 3 minus g of 0. Okay, plus, now I'm going to need this second integral, and an antiderivative, well, okay, the 3, that just gets pulled out. And what's left over? Well, I take an antiderivative, just as I did here, and I get negative 1 over s e to the negative st, and we're going to evaluate that between 3 and infinity. All right, this infinity requires just a little bit of care, but we'll handle that when we get to it. So let's see, what is our g of 3? So we just evaluate this function at t equals 3. So that's pretty easy. We have negative e to the negative 3s, and then we'll have 3 over s plus 1 over s squared. So 3 over s plus 1 over s squared. Okay, how about the minus g of 0? So minus, okay, now when we do g of 0, the exponential will just become a 1, because t is 0, e to the 0 is 1. And there's a minus, so that actually will make this into a plus. And what's on the inside? Well, t is 0, so this first summand goes away, and we're just left with a 1 over s squared. All right, now let's go to the second piece. So we have a 3, and then we're going to multiply by, well, what goes on the inside. So what we need to do is evaluate this at infinity. And of course, what that really means is we take the limit as t goes to infinity. Now, we've shown repeatedly in class that if you have a decaying exponential, as t goes to infinity, this will go to 0. And since there's no other t's to worry about, this is not a serious problem multiplying by negative 1 over s. It's just a constant. This whole expression will go to 0 as t goes to infinity. So we're going to end up with 0 here. If we want explanation, since e to the negative st is a decaying exponential. Okay, then we're going to subtract what happens when t equals 3. Now, when we subtract a minus, we'll get a plus, and then we'll have 1 over s e to the negative 3s. Okay, so we have now found everything. I guess we could do a little bit of simplification if we want. So maybe we'll do one step, because I notice here, let's see, we have a 3 over s and an e to the negative 3s, with a negative. And we also have, a positive 3 over s e to the negative 3s. So it looks like these pieces are actually going to cancel. And what are we left with then? Well, we have a 1 over s squared. And then, of course, we have this decaying exponential times 1 over s squared. So I can factor out that, and I'll get 1 minus e to the negative 3s. Looks pretty good. Looks pretty good. Take care, everybody.